Welcome to my kitchen and to your 2-in-1 lesson, baking plus physics. I will be your teacher today and here are my credentials. Here's what we'll be doing today. They're called whoopies. And here's what we'll get by the end of the video. So, I hope you will enjoy, and without further ado, let's get started. Let's start with the ingredients. For the dough, we will need 100 grams of milk chocolate, 50 grams of dark chocolate, 100 grams of butter, 3 eggs, 125 grams of powdered sugar, 200 grams of smooth flour, 1 packet of vanilla sugar, 1 coffee spoon of baking powder, 2 soup spoons of cocoa powder, 1 coffee spoon of cinnamon, 1 packet of custard powder. For the filling, we will need 1 packet of custard powder, 500 milliliters of milk, 50 grams of powdered sugar, and 250 grams of mascarpone. And finally, for decoration, we will need 1 packet of dark icing. Okay, we'll start by preparing a water bath for both of the chocolates and the butter. Please enjoy this short montage of me stirring while I talk about the physical processes that occur while melting chocolate and butter in a water bath. Let's start with heat transfer by conduction, which means that heat flows from the hot water to the pot and then into the chocolate and butter. Heat transfer by convection also occurs because the water circulates naturally and distributes heat evenly. Another phenomenon that's going on is the melting of an amorphous substance. Chocolate does not melt at a single fixed temperature but softens gradually, unlike crystalline substances such as ice. A pretty obvious one is phase change because chocolate and butter change from solid to liquid. Now, why am I even stirring it? The effect of stirring is that it improves heat distribution. Without stirring, chocolate would heat unevenly and could overheat locally. You may be wondering why the water is not stirred but the chocolate is. Well, the answer is that water has low viscosity and natural convection occurs, while chocolate is much more viscous and requires mechanical mixing for uniform heating. Is this all right? Yes, past Diana, it is all right. What we've observed is boiling water. When heating the water bath, the water may reach its boiling point. The observed physical phenomena include boiling of a liquid, phase change from liquid to gas, which is what startled me, formation of vapor bubbles, and dependence of boiling point on pressure. Right now, we are letting the mixture cool after melting, and this is actually also a physical process. Yes, it is. After melting, when the chocolate mixture cools, heat is released to the surrounding air, molecular motion slows down, and the viscosity of the mixture increases slightly. In translation, that means that the mixture becomes thicker. Okay, meanwhile, we can get started on mixing our dry ingredients, which will be flour, custard powder, cinnamon, baking powder, and cocoa. And I was wondering why we're not mixing the sugars into this. And that's because the sugars need to be dissolved and not only dispersed in order to create a homogeneous mixture, and these ones only need to be dispersed. So, okay, now we will check if our mixture is cool enough. It's not.
Eternity later.
Alright, I should have poured it into the bowl, let it cool, and then added these things, but as you can see, using physics can actually save you time. I admit, leaving the chocolate in the pot and hoping it would cool down fast was not my brightest moment. After my chocolate mixture finally cooled down, I combined it with eggs, powdered sugar, and vanilla sugar. Here we have a mix of chemistry and physics. Mechanical mixing causes homogenization. Liquid fat is physically dispersed in the water-based mixture, and some air remains trapped in the batter. While adding the dry ingredients, they are physically dispersed throughout the batter. Solid particles absorb water, and batter viscosity increases as particle motion becomes restricted. This is yet another example of how physics and chemistry work together in cooking and baking. Meanwhile, we will preheat our oven to 165 degrees. When filling the pastry bag with dough, my mom advised me to use a rubber spatula rather than a wooden spoon. From a physics point of view, the rubber spatula has lower adhesion, so the dough slides off easily and fills the bag with less force. Piping the batter through a pastry bag clearly demonstrates Pascal's law. Pressure applied by the hand is transmitted through the batter. The batter then flows through the narrow opening. Gravity causes slight spreading after deposition, and surface tension helps maintain rounded shapes. The same physical principles will also apply when piping the filling. When baking the whoopie pies in the oven, heat transfer occurs, with convection of hot air inside the oven and conduction from the baking tray to the batter. There is also thermal radiation from the oven walls. Additional physical phenomena include thermal expansion of gases, meaning that trapped air expands, increasing the volume of the batter, evaporation of water from the surface, and thermal capacity. The metal tray has a higher thermal capacity than the cake, so it remains hot longer and cannot be touched immediately after baking, unlike the cake. So we will continue with preparing the milk. Add 100 milliliters to a bowl. Around that much. And add powder in there. Mix the powder with the milk. Then heat the rest of the milk and mix it with the powdered sugar. Lastly, carefully mix the two mixtures together. Heat causes the starch granules to absorb liquid and swell. The mixture thickens as particle motion becomes restricted. While mixing pudding with mascarpone, mechanical mixing disperses fat droplets. The filling becomes smooth and uniform as a result, and small amounts of air may be incorporated. While the baked pies cool, heat is transferred from them to the environment. Steam escapes from the interior, and moisture redistributes evenly throughout the structure. While filling and assembling the whoopie pies, the filling spreads under applied pressure. The cake layers are slightly compressed, and the filling adheres to the porous cake surfaces. The last step is to apply the chocolate glaze. Firstly, we will melt it in water. The glaze melts due to heat. The liquid flows under gravity. Surface tension smooths the glaze, and cooling causes the glaze to solidify. Overall, the preparation of whoopie pies demonstrated many physical phenomena, including heat transfer, phase changes, pressure in fluids, mechanical work, viscous work, gas expansion, thermal capacity, evaporation, and cooling. And I must say that they were very delicious. Thank you for watching the video. I hope you enjoyed, learned something new, and will maybe try the recipe and see for yourself.